In this video, we will start a transitive relation on set A. A relation R is a transitive relation. If A is related to B and B is related to C, then A is related to C. Means if there are, let's say, three elements A, B, and C that are belonging to A, such that A is related to B and B is related to C, then A must be related to C also. For every ABC, for every such ABC where A is related to B and B related to C, then A should be related to C. So how it is? It is like this: that if there is a relation from A to B, if A is R related to B and B is R related to C, it means that A is also R related to C. A is also R related to C. Okay. If this holds for every such three elements, then such a relation is transitive relation. Now let's take some example. A is equal to 1, 2, 3, 4, 5, 6, 7. Okay. Now for any relation R, if we are going to represent it as a directed graph, corresponding directed graph to any relation, then the vertices set is going to be is the set A. So let's say this is your 1, 2, 3, 4. Now let's suppose that 1 is related to 1. Let's suppose I have a relation R1, okay, and R1 has this 1 comma 1 as this element. Then this is represented as this. Now let's say 2 is related to 1. 2 is related to 1. So far is this relation R1 transitive? Yes, because if you see, 2 is related to 1. 2 is related to 1 and 1 is related to 1. There is no violation to this property so far. So far this relation is transitive. But if let's say 1 comma 3 is also one of the pair in this relation. If R1 is just this much, means R1 has only three ordered pairs which are this. Now is R1 transitive? No. R1 is no longer transitive because as you can see that 2 is related to 1, 1 is related to 3, but 2 is not related to 3. So it is not transitive. Looking from the graph perspective, if you see there is a directed edge from 2 to 1. Now if there is a directed edge from 2 to 1, for this whole directed graph to be transitive, wherever there is a directed edge from 1 to any other node, there has to be a directed edge from 2 also. Then only it will be transitive. So this will become transitive only when you have this directed edge, which is 2 comma 3. So as you can see, it will become transitive only when you have 2 comma 3 also belonging to R. Then only R1 will become transitive. So this is a thing for transitive relationship. You can look at the elements of the relation and you can find out if it is transitive or not, or you can look at the graph and you can find out if it is transitive or not. I think this is the more easier. Actually, this is also easier. If you means it's very simple. What we have to see is this 1 comma 1. So it is about the same element. One is related to itself. But the moment we have two distinct elements, you see 2 and 1. The moment you have two distinct elements, 2 is related to 1. Now what you are going to see about the rest of the, when you are checking that R1 is transitive or not, you come across a element, an ordered pair of 2 comma 1. Now what you have to do is you have to see which other elements is 1 related to, and to all those elements is 2 has to be related. Means 2 has to be related to all those elements. That's what you have to do, right? This is R1. R1 is not transitive, but let's say you have R2, which is 1 comma 1, 2 comma 1, and 1 comma 3 and 2 comma 3. 1 comma 3 and 2 comma 3, then R2 is transitive. Let's say there is R3. R3 is 1 comma 1, 2 comma 1, 1 comma 3, 2 comma 3, and apart from that, let's say 5 is related to 2. 5 is related to 2. Now, for this relation R3 to be transitive, you have to look at a directed edge, which is not self-loop. If you look at the directed edge, which is not self-loop, now, so 2 is related to 1. Now from 1 to wherever there is directed edge to whatever nodes, there has to be directed edge from 2 also. So from 1 you have a directed edge to 3, so you must have a directed edge from 2 to 3. So looking at just 2, you can say that okay, so far by looking at node 2, I think okay, this is satisfying transitive. What about 1? 1 is related to itself, 1 is related to 3. Now for 1 this 3 has to be wherever the 3 is related to, wherever 3 is related to whatever, 1 also has to be related to that, right? Now 3 is not related to anything else, so it's okay, there's no problem with it. Looking at 5 now, from this directed edge you get that 5 is related to 2. Now what will happen is that wherever the directed edge from 2 is going, you must have a directed edge from 5 to that also. So from 2 there is a directed edge to 1, but there is no directed edge from 5 to 1, so it is not transitive. From 2 you have a directed edge as 3, from 5 you don't have a directed edge to 3, so it's not transitive. Look at here, what I can say is that from 5 is related to 2, and 2 is related to 1, but 5 is not related to 1. This is your definition. Just from the list of ordered pairs in the set, from here also we come to the same conclusion. Okay, that 5 is related to 2 and 2 is related to 1, but 5 is not related to 1, so not transitive. So R3 is not transitive. R3 is not transitive. There's another way why R3 is not transitive, which is 5 is related to 2 and 2 is related to 3, but 5 is not related to 3. So R3 is not transitive. Okay, we'll take some more examples. Let's say R4 is, uh, just write this all of this 1 comma 1, 2 comma 1, 1 comma 3, 2 comma 3, 5 comma 2. Okay, and I have to make it transitive. If I have to make it transitive, then there should also be an age from 5 to 1. Okay, now see this. If you have to make it transitive, then you have to make an age from 5 to 1. because if 5 is related to 2 and 2 is related to 1, then 5 must also be related to 1. Okay, or there is a directed edge from 5 to 2, and from 2 there is directed edge to 1 and 3. So there has to be a directed edge from 5 to 1 and 5 to 3. Okay, so now if when you do this, now this R4 is transitive. Now this R4 is transitive. So R4 is transitive. Let's take more examples. You have R5, which is 1 comma 1, 1 2 comma 1, 1 comma 3, 5 comma 1, 5 comma 3, 2 comma 3. Okay, these are just ordered pairs related to each of these directed edges. Now let's say there is 3 comma 4 also. In your R5 you have 3 comma 4 also. Now now look at this. 2 is related to 3 and 3 is related to 4, so there must be a edge from 2 to 4. If R5 has to be made as a transitive relation, so far till this point this is transitive. Now you are adding one more ordered pair, 3 comma 4, which means to say there is a directed edge from 3 to 4. Now for R5 to be transitive, 2 is related to 3, so and 3 is related to 4, so 2 must be related to 4 also. 5 is related to 3 and 3 is related to 4, so 5 must be related to 4 also. And then 1 is related to 3 and 3 is related to 4, so 1 must be related with 4. Now R5 is transitive. Now this directed graph, if you look at R5, this is the corresponding directed graph of R5, and there are three components to it. There are three components in this directed graph. If this is your graph that is associated with R5, then it has three components. Okay, six component. One component is just having 6, and another component is just having 7. So these are isolated vertex in your graph, and this is one connected component, right? And if you look at the connected component carefully, if you try to observe something, then from 5 there is no incoming edge to 5. This is your connected component. Just focus on the connected region, connected component. There is no incoming edge to 5, right? So just look at 5. Just look at 5. There is no incoming edge to 5. Then 5 would there would be a directed edge from 5 to every other nodes that is in the connected component. So there is a directed edge from 5 to 1. There is a directed edge from 5 to 3. There is a directed edge from 5 to 2. There is a directed edge from 5 to 4. Right? Okay. Now look at 5. Look at 2 now. Look at 2. Look at 2. So if I can just write it down, my observations, let me write it down the observations. For 5, node 5, there is no incoming edge, no incoming edge. ठीक है. For 5 there is no incoming edge, and for the in the connected component, then 5 has a directed edge to every other node. Directed edge from 5, from node 5 to every other node in the connected component. To every other node in the connected component. If you look at node 2, so just look at this node 2. For node 2, there is a incoming edge from 5. There is an incoming edge from 5 to 2. There is no other incoming edge. Only one incoming edge to 2 from 5. Okay. And you can see there is one incoming edge. One incoming edge from node 5. And if you can observe, I'm going through a sequence. Like I have started from 5 with on a purpose. I have started observing, means I am writing all these observations starting from 5 on purpose. Okay. So one incoming edge from node 5 to node 2, there is one incoming edge from node 5. Now there is outgoing edge, directed edge from 2 to every other node except 5. Directed edge from node 2 to every other node in the connected component except for node 5. Now let's look at node 1 now. Node 1. For node 1, you have an incoming edge from 5 and 2. Incoming edge from 5 and 2, from sorry, incoming edge from 5, incoming edge from 2, right? So from 1 to other, you have an outgoing edge to every other node in the connected component except for 5 and 2. You have a directed edge from 1 to every other node in the connected component except for node 2 and 5, right? Similarly, you can see that for node 3, I'm not going to write it. You can see the pattern, what is happening. For node 3, there is an incoming edge from 5, there is an incoming edge from 2, there is an incoming edge from 1. Okay, so there is going to be an outgoing edge from 3 to every node except the nodes from where the incoming edges are coming. So from 3 you will have an outgoing edge from 3 to 4. And for 4 you can see there is no outgoing edge from 4, because from every other nodes in the directed graph, in the connected component, every other node there is a directed edge to the 4, right? So can you make up something from this observation? Can you make up something from this observation? Yes. What is it? That if one is for in the connected component of a transitive relation, in a graph which is a graph of some transitive relation, in the graph of some transitive relation, the incoming edges, any incoming edge to a node, if one is having an incoming edge from 2 or from 5, then it means that one is not related to 2 or 5. One is not related to 2 or 5. From 1, every other node like 1 and 3, 1 and 4, whatever the outgoing edges from 1 is, 1 are, these are because of these outgoing edges, the directed edge from 5 to 3 or directed edge from 5 to 4 is because of the transitive constraints. This is my R5, right? So if you just look at node 1, then node 1 there is a directed edge from 2 and there is a directed edge from 5, means that 2 is related to 1, means that 2 comma 1 is a part of your is an element of your relation, and 5 comma 1 is a element of your relation. Okay. Now and then there is outgoing edge from 1 to 3 and 1 to 4, 1 to 3 and 1 to 4, and these edges from 5 to 3 or 5 to 4, from 2 to 3 or 2 to 4, these edges are there to satisfy the transitive constraint. 5 to 3, 5 to 4, 2 to 3, 2 to 4. This has to be there to satisfy the transitive constraints.